Welcome you all. In this session, we are going to discuss the pinouts in 8085 microprocessor. After successful completion of this session, the student could able to explain the functions of various signals in 8085 microprocessor. 8085 pin description. Manufactured with NMOS technology, it has 40-pin IC package. It has 16-bit data address bus. Thus, it has 2 power 60, that is 64 kilobytes capacity. Operate with 3 megahertz of clock pulse, and the supply given is plus 5 volt. See over here, pin number 12 to 19. So these can be used for transferring both the address and data. So here, how the processor identifies whether the signal given is a data or a address. It's based on this pin, that is the pin number 30, that is ALE, address latch enable. So here, based on the signal of ALE, it determines whether the signal applied to AD0 to AD7 is a address or data. AD0 to AD7 will be data. If it is low, then it will be the address. Next one is IO/M. It is the output signal which distinguish whether the address is for memory or IO device. When it goes high, the address on address bus is for a IO device. When it goes low, the address on this address bus is for the memory location. S0 and S1. These are the two output signals sent by the microprocessor to distinguish the various operations. So here the truth table shows the operation performed by the processor based on the signals on S0 and S1. If both S1 and S0 are 0, then the halt operation will be performed. That is, the processor will be in idle state or stops the execution, halt. That is the second. If suppose the second condition is, if suppose S1 is 0 and S0 is 1, then the write operation will be performed. If suppose S1 is 1 and S0 is 0, then the read operation will be performed. And the final case is, if both S0 and S1 both are 1, then the fetch operation will be performed. Read operation. It is the output signal. It controls the read operation. When it goes low, selected memory or IO device is read. Write operation. It is a output control signal. It controls the write operation. When it goes low, the data in the data bus written into the selected memory or IO location. Read. It is used as ready. It is used by the microprocessor to sense whether the peripheral is ready to transfer the data or not. A slow peripheral may be connected to the microprocessor through ready line. If ready is high, peripheral is ready and the data transmission can be done. And if suppose it is low, then the processor waits until it goes high. Hold. It indicates that another device is requesting for use of address and data bus. After receiving the hold request, the processor hand over the control of bus to the devices as soon as the current machine cycle is completed. Internal processing may continue. The processor regains the control over the bus after the removal of hold signal. When hold is acknowledged, address bus, data bus, read, write, and IO/M bar are tri-state. Hold is sampled in T2 clock signal. HLDA, that is hold acknowledgement. It is a signal for hold acknowledgement. It indicates the hold requests have been received. After removal of hold request, HLDA goes low. The CPU takes over the bus half clock signal cycle after the HLDA goes low. INTR, interrupt request signal. Among interrupts, it has the lowest priority. When it goes high, the program counter does not increment its count. The microprocessor suspends its normal sequence of instructions. After computing the instruction at hand, it attends the interrupting device. The INTR line is sampled in the last state of last machine cycle of an instruction. The INTR is enabled or disabled by a software. An interrupt is used by I/O device to transfer data to processor without wasting time. If CPU is in hold state or the interrupt enable flip-flop is reset, the interrupt request is not honored. INTA, interrupt acknowledgement. It is an interrupt acknowledgement sent by the processor after the interrupt is received. RST 5.5, 6.5 and TRAP. These are all the interrupts. When an interrupt is recognized by the next instruction is executed from a fixed location, the memories are given below. So the various interrupts and their vectored memory location has been tabulated in the table given here. Reset. It resets the program counter to 0. It also resets the interrupt enable and HLDA flip-flops. It does not affect any other flag or register except the instruction register. The CPU is held in reset condition as long as a reset is applied. Reset out. It indicates the CPU is being resetted. X1 and X2, these terminals connected to an external crystal oscillator which drives an internal circuitry of the processor to produce suitable clock of operation of microprocessor. Clock. It is the clock output for user which can be used for other digital ICs. So if you are connecting some peripheral device, I mean, if suppose if you want to synchronize it with the processor, then you can use this clock signal out pin to connect it as a clock signal for that particular device. SID and SOD. SID, it is the data line for serial input. The data on this line is loaded to the 7th bit of accumulator when RIM instruction is executed. SOD, it is a data line for several output. The 7th bit of accumulator is output of SOD line when SIM instruction is executed. VCC, that is plus 5 volt supply, will be provided to this pin, and VSS is the ground pin. Thank you.